Good morning. Welcome to this morning's webinar on electrical safety in the workplace, the 2018 edition of 70E. First things first, I know you'll all probably have a lot of questions, so if you notice on the right-hand side of your toolbar there's a little drop-down for questions. Simply type your questions into that message bar, and we will answer all questions at the end of the presentation. One of the most popular questions we get is, do I get a copy of the presentation? And the answer to that is absolutely. At the end of the webinar, you'll get a thank you email from us. Please just respond to that email requesting a copy of the presentation, and I will get that out to you in the form of a PDF. Also, if you have to miss some of the webinar, or if somebody in your organization misses some of the webinar, we will have this up on our YouTube channel, hopefully by the end of today, certainly by the beginning of next week. So it will live there for you to view at your leisure anytime you need to. With that, though, I'd like to introduce our speaker today. Bob Clukey is a TPC Training electrical instructor. He's also an electrician, and he has decades of experience in electrical safety and is one of our top electrical instructors here at TPC Training. So without further ado, I'd like to welcome Bob Clukey.
Thank you, John, and welcome everybody on this call. So today we're going to go through the upcoming changes that the 2018 edition of 70E is going to give us. I want to let you know that this presentation has been based on the second revision and plus the NFPA conference that was held in June. The 70E will be available for us to purchase on September 25th, so just a few more days, and we'll be able to actually have the PDF in our hand. First, I'll give you a little bit idea about TPC Training, who we are. So we like to say that we are a full-service training company, and we have product TPC Online, where we do training in your facility in an online format. We also will do consulting to see if we could help you with really anything in your facility, from mapping out your machines with our iSchematic format, or having actual live instructors come through TPC Training. So we have online courses, we have consulting services, we have opportunity to map out your machines, your hydraulic systems, your electrical systems, pneumatic, and also live instruction. Okay, and John already mentioned about me, but you get to see a picture there, so that is fine. And we'll get right into the meat of the program. So the first change that comes up is in the scope of NFPA 70E, and this aligns with the National Electrical Code, what they did with the 2017 code, that now the removal of conductors equipment is now covered under 70E. So if we are removing equipment, then all of the safe work procedures in 70E should be in place. Notice if you do see something underlined, then that is the change. So when we look at the second revision on the NFPA website, this is exactly what we would see. This was copied and pasted right from there. So in definitions, arc flash hazard, they now put in a source of possible injury or damage to health. So I want to understand that the arc flash is a tremendous amount of heat, and gave us this definition to help clarify that. Electrically safe work condition in definitions has also been changed just a little bit. And in a minute, we're going to see that there are even more steps now to achieve that electrically safe work condition. In the 2015 version and prior editions, there were 6 steps. Now there are 8 steps. But in this definition now, you can see that they have put in the word verify the absence of voltage, and if necessary, temporarily grounded for personnel protection. Of course, usually that happens a lot of times with higher voltages that we have to put those ground straps on, but they wanted to get that in the definition. So I did mention that there are now 8 steps to establish an electrically safe work condition. This is one of the steps that we always had. We had to identify all possible sources of power coming to the equipment. And this step also was one that we had to properly interrupt the load current and then open up the disconnecting means. And the visual verification was always in there also. This is brand new. So now we have to release stored energy, and this could be capacitors, you name it, whatever it might be, but we've got to make sure that all stored energy is now no longer at the machine. And brand new, step number 5, we have to block that stored mechanical energy. So whatever it might be, gravity, whatever it could be, now we've got to not just have a good understanding of the electrical functioning, but we also have to understand the mechanical ability of that machine. So we have to be able to block all stored energy, and that is going to be very nice for technicians to keep themselves much safer. This one was always in there also, and this is of course lockout tagout. And then our live dead live step, so using the right category of meter, we would go ahead and verify that we were de-energized, and phase to phase, phase to ground, so make sure that that says 0, and test our meter before we do that verification step and after. And then lastly, we always had this one, which well, this one's a little bit different. This one is some exceptions to that live dead live. So this is kind of new. So exception number 1, an adequately rated permanently mounted test device shall be permitted to be used to verify the absence of voltage. Okay, so that means that I do not have to have a qualified worker go into that piece of equipment and actually use a meter. I can permanently mount a test device in that meter, and I'm going to show you a picture of this right after this slide, but we do have to meet some requirements, right? So it is permanently mounted and installed in accordance with the manufacturer's instructions. Test the conductors and parts at the point of work, where we're going to be working. Has to be listed and labeled for the purpose of verifying the absence of voltage. It does the same thing that we would do if we were doing it, manually. It tests each phase conductor, phase to phase and phase to ground. And the test voltage is verified as operating satisfactorily on any known voltage source before and after verifying the absence of voltage. So basically, this device does the exact same thing that we would do if we were doing it manually. And here's what it looks like. Just one manufacturer of these. There's a lot of almost every company has these now. So this can be permanently mounted inside of a piece of equipment. It verifies it's working properly before it goes ahead and tests phase to phase and phase to ground, and then it verifies it's working properly afterwards. And it gives you an indication. You will get an indication right here when it is safe to work on that piece of equipment. So that is excellent. That could save our technicians from having to put on a lot of extra personal protective equipment. And to give you a little bit of idea about these, they are permanently mounted test devices, and they can do AC or DC. And really, it takes away the chance of having an operator error. They are listed. The UL standard for these is 1436, new product category, and they've been out now about for a year. So NFPA 70E recognized those, and that's a great proposal. And the last step, of course, has always been in there also. This used to be step number 6. It's now step number 8. If we do have the possibility of induction or capacitance, then we would have to put ground straps on. They gave us some new definitions also, and they did a good job with this, I believe. A lot of the terminology in 2015 might have said short circuit current. Well, now they really want to get to fault current to include not just short circuits, but also ground faults. So available fault current, the largest amount of current capable of being delivered at a point on the system. And so we'll take a look at what they gave us for new for these definitions, which is a diagram. So now you can see that this would be right in Article 100, right near these definitions when we get our document in our hands. And, and we have a source. So whatever that source might be, that source, of course, could be the utility. It could be photovoltaic system. It could be our generator, whatever. Fuel cells now, I notice, are becoming very popular. But then gives us a little diagram to show us that the available fault current close to the source, of course, is probably the highest it's going to be. And then when it gets down into the equipment, it could, become lower as we add impedance to that circuit. Also gives us an idea about short circuit current rating for our equipment to make sure that it is rated higher than the available fault current. Talks a little bit about interrupting rating so that our overcurrent device can have a higher interrupting rating than the available fault current. So very nice that they put this in, and they've done a lot in this document with fault current. So very good that they gave us a nice diagram here. Condition of maintenance. So this one is a pet peeve of mine because sometimes it's real tough to satisfy this requirement out in the real world. And you can see that they've played with this definition a little bit because we have some words that are underlined. So the state of the electrical equipment, considering the manufacturer's instructions, which are real good. I mean, if we're going to maintain a piece of equipment, the manufacturer's instructions should help us tremendously. And manufacturer's recommendations. Then it goes on to say applicable industry codes and standards. So NFPA 70B, our publication for maintenance, would come into play there. And then recommended practices. So when we look at the condition of equipment, we've got to make sure that we're taking all that into consideration. We've got to make sure that the equipment has been maintained properly. They changed a little bit qualified person. So seems like every revision they play with this definition a little bit. But basically it always has been a person that can demonstrate that they do have skills and knowledge related to the equipment they're going to work on and has received some safety training to identify the hazards. And now they put in and reduce the associated risk. So risk assessments are extremely important in NFPA 70E. Before we approach a task, we've got to do some type of risk assessment here to identify those hazards, to mitigate those hazards, and they give us a hierarchy how we can do that, and I'm going to show you that coming up here. But risk assessments have now even been put in the definition of qualified person. So you can see they have played a little bit with risk assessment. So it tells us that our electrical safety program shall include a risk assessment procedure, and it has to comply with H1 through H3. So we have to have a way that we can accomplish this. And I like to put it all in one form. If I can do a job briefing, if I can do shock hazard analysis, and then do my risk assessment all in one form, that's just the best way to do it, I do believe. But the elements of my risk assessment procedure, they have to address the employee exposure to electrical hazards. They got to identify the process. And so they give us really 3 steps, right? First, we have to identify the hazards. So looking for electrical hazards, shock, arc flash, or arc blast, but there could be other hazards. We could be in an environment where it's dust or vapors or whatever, so it could be in some classified locations. But whatever those hazards are, we've got to identify those. Then we've got to assess the risks. So we've got to put a little bit of a percentage on this. What are the chance that a worker might get a shock? So now you've got to really be able to identify your qualified workers and their skills, and are they wearing all their PPE, things like that when you assess the risk. And then we've got to implement risk control, and they give us a hierarchy we can use, and they give us some methods for risk control. So let's take a look at those, and we'll see what those are coming right up here. The first one, though, I did mention when I was back on this slide about assessing those risks, that human error has to come into play here. So we have to have that procedure built so that it can address the possibility of human error. So let's face it, if we have a worker that has 35 years experience working on that piece of equipment and he is highly qualified, that's different than if we have a worker with maybe 6 months worth of experience. So you have to have some type of evaluation in your audit form to make sure that you are addressing that. Then in the informational note, they tell us that we can go to NXQ, and it's going to help us to be able to determine the ability of our workers. And then number 3 is that hierarchy that I mentioned before, and we should take a look at that right now. So here you can see the front cover of the new edition, the 2018 edition, and they thought that the hierarchy of controlling the hazards was so important, they put it on the front cover. So let's see here if we can make this. So the first one is elimination. So when we try to reduce those risks, and the NFPA gives us choices, their first choice is always their preferred choice. So they would like to have us eliminate the risk completely. So that would be establishing an electrically safe work condition, de-energizing, just getting rid of all the hazards completely. And then we'll see number 2, substitution. So a good example of substitution would be that meter that we permanently install in our equipment. So I'm not going to have my workers go in there and test for a voltage and verify it's de-energized. I've substituted a different method. I've put in a meter there that's there all the time. And then we have engineering controls. The example I like to use here is if we have a worker that might go in and reset an overload once in a while, and they have to open the door up and reach in and press that overload. Well, maybe we can just relocate that overload to the outside of the equipment so that they don't have to open anything up at all. And the next one, awareness. So if we are at a piece of equipment, let's say that's 4160, we have to really make our workers aware of that, have the proper labels on there, and they just have to be aware that there's additional hazards here because the voltage has increased so much. Administrative controls. So the administration or management of the facility could say that only Joe and Jerry are going to work on this equipment, nobody else, or whatever they want to determine. But we could do some of this mitigation through administrative controls. And then our last form of controlling these hazards is our personal protective equipment. So remember, the NFPA gives you these choices 1 through 6, and look, their last choice on how to keep a worker safe is personal protective equipment. And too many times out in the field, that might be a person's first choice, that they're going to put that on first. Well, that's really not what OSHA and the NFPA want to see. They'd like to see us try to utilize those top 5 before we ever get to number 6. In the electrical safety program, in 110.1b, you can see inspection. So now, if I have some newly installed equipment or modified electrical equipment, I've got to make sure it's been inspected to make sure that it complies with the National Electrical Code, the manufacturer's recommendations, any other standards that might be out there prior to being placed into service. So I'm not sure if you understand this part or not, but OSHA loves everything documented, right? So when this inspection occurs to equipment that was newly installed or modified, I would make sure that we documented that inspection. Now, that could be a self inspection. You could have an engineering team and they could come out and inspect it themselves. That could be an outside entity. You could have an electrical inspector come in and inspect that. But Or you could even have maybe the manufacturer of the equipment come and see if it was installed correctly. So it just has to be something that is documented and somebody has said, yes, this is good to go. We can now energize and make this happen. They gave us a new informational note for shock hazard. So informational note is now talking about injury and damage to health, and it telling us that shock is dependent on the magnitude of the current, the power source, the frequency has a huge determination in if we're going to get hurt or not, and the path and the time duration. So they did a lot with shock and statistics with their new Annex K. So Annex K has changed quite a bit, and when you do receive either your PDF or your hard copy, you can take a look now at Annex K. They've updated all their statistics and facts about shock, so they also gave us this informational note. Working distance, they played just a little bit with, and I find that when I teach live seminars, a lot of people just don't understand working distance. So basically, this is where we're going to make a prediction of how much energy is going to come at the person's face and chest area. So if we are below 1,000 volts, that working distance is usually at 18 inches away. So we have to understand, okay, at 18 inches away, we made a prediction, 7 calories per centimeter squared of incident energy. Well, that's great. I don't think personally at my age that I can work 18 inches away from equipment. I believe I've got to get a little bit closer. So they gave us this note that said that incident energy increases as the distance from the arc source decreases. So when I get closer, that 7 calories has gone up. And I've got to make sure that my arc-rated clothing will reflect that as I get closer. Definitely my eyes have probably got to get closer, and my hands have to get closer. But they're talking about your face and your chest. If you can keep that 18 inches away, then you would be at that incident energy level that we did predict at that piece of equipment. Next, we're getting out of definitions now, and we get up into Article 105, and employer responsibility. Just about everything falls on the employer, whether it's OSHA's Code of Federal Regulations, 1910 and 1926, or NFPA 70E. So the employer shall have the following responsibilities: establish, document, and implement the safety-related work practices and procedures required by this standard. So you have to have an electrical safety program, and it has to be documented, and you have to use it. Also, you have to provide employees with training in the employer's safety-related work practices and procedures. That training also should be documented. So, but you have to have that training down. The employee responsibility, a little bit there. Pretty much every place that we look at, we'll see that the only thing that the employee has to do is follow the rules. So whether it's OSHA or NFPA really doesn't matter. So the employee has to comply with all the work practices and procedures that the employer has provided to them. So, but even though the employee shall comply, it is still up to the employer that they are complying. So inside your electrical safety program, you should have something for consequences. We just can't let these technicians out there working with no PPE or whatever. They have to follow what we have in writing. And then 105.4, and I've mentioned this already, but out of the 6 mitigation techniques we have, the number 1 is elimination. So that's the first priority in the implementation of these safety-related work practices. And that's true of any NFPA document. When they give you choices, number 1 is the best choice. We get up now into Article 110. If you do have an incident in your facility, we are going to now have to have a little investigation here. So the electrical safety program shall include elements to investigate electrical incidents. And these could be near misses, close call, whatever they might be. But the theory behind this is that if we do an investigation, then we might be able to prevent this from happening again. Why did we have this close call? Why, you know, and try to help solve that problem, get to the root cause, and just make sure it doesn't happen to another worker. Also in 110, they tried to move all their training requirements in one section now. And so here, emergency response training. So if you have first responders, also if you have people that are exposed to shock hazards, then they have to be trained in how to release a victim from an energized circuit. And that training has to occur annually. So we're talking now about how to release a worker from a circuit that is energized and they're locked onto that circuit. So that's the first part, exposed to shock hazards. The second part, now we're looking more at CPR and AED. This also used to be an annual training, but if you look down into D, training shall occur at a frequency that satisfies the requirements of the certifying body. So that's nice because the Red Cross or the American Heart Association, they usually issue cards that are good for 2 years. So now that training can just coincide with their requirement. It used to be that training had to be every year. So that's a nice change for us. GFCI. So the thing that changed here is that there is a new revision to the UL Standard 943, and this requires all manufacturers to give us GFCIs with a self-test feature. So they're going to test themselves. We don't really have to test them, and if there is a problem when they go through their self-test, they are automatically going to trip and they are going to be de-energized. They are going to provide us with a light or some type of audible indication, but the manufacturer will now provide that to us. That is excellent because, let's face it, how many people went out and tested their GFIs every month like we're supposed to? So this is going to be very nice. Article 130, which is pretty much the heart of NFPA 70E, and the first change we see in there is normal operating condition. So there used to be that we had 5 conditions that we had to satisfy before we could go up and operate a piece of equipment normally, but now they've added one here. And so number 1 was always there, properly installed. Number 2, always there, properly maintained. Properly maintained, by the way, in my opinion, is tough because it has to be maintained in accordance with those manufacturer's instructions and applicable industry codes and standards. I always use, for an example, a molded case circuit breaker. I mean, how many of us go out and test the torque on that once a year? I mean, we might do thermal imaging. How many of us meg that plastic out? So it's tough to get properly maintained, but I mean, hopefully we can strive to get there. Number 3 is the brand new one, and if you're familiar with the National Electrical Code, this did come out of 110.3b of the National Electrical Code, that the equipment has to be used in accordance with the instructions that were included in UL listing and labeling or any testing agency, and in accordance with the manufacturer's instructions. So we better hang on to those instructions because they become part of the National Electrical Code. A good example that I could use, I guess, here would be sometimes I'll walk into an office building, I'm going to perform some electrical work, and I happen to see these little electric space heaters underneath the desk. Well, if we look at the instructions that come with that space heater, it will flat out tell us residential use only. Cannot be in a commercial or industrial building. So those manufacturer's instructions become extremely important. 4, 5, and 6 are not new. They were all there in 2015. But these are the 6 conditions that we would have to satisfy to go up and operate a piece of equipment normally, just the way the manufacturer wants us to. We shouldn't have to be wearing any PPE during this time because there should be no opportunity of shock, arc flash, arc blast. All the covers are on. The equipment's working great. So, of course, if you walked up to a piece of equipment and you could tell immediately by looking at it that it has arced before, or that there's screws missing in the cover, which is not maintained properly, then we should be putting our personal protective equipment on to service that equipment. Still, in Article 130, working while exposed to electrical hazards, they tell us here if additional protective measures are required, they have to be selected and implemented according to the hierarchy of risk control. So, again, eliminate, substitute, all those. When the additional protective measures include the use of PPE, so we got all the way down to number 6, then the following has to be determined. The appropriate work practices we're going to use, we better know the arc flash boundary. So the arc flash boundary would be determined either by the incident energy analysis method or the PPE category method. And then the PPE that we're going to use inside that arc flash boundary. And Table 130.5c can give us an indication that if we are going to have to use these additional protective measures or not. So I took a little bit of that table and I wanted to show it to you. So 130.5c, this table was also in the 2015 version of 70E. But if we take a look at it now, this does apply to the incident energy analysis method and the PPE category method. There was in the 2015 version, a lot of people were under the impression that this only could be utilized with the PPE category method. But if I've generated my label with the incident energy analysis method, I can certainly use this table now. And if we come down to the part that's underlined for AC systems, and we work on energized conductors and circuit parts, including voltage testing. So we know we're energized, right? It comes over, and the equipment condition, it doesn't matter. If it's brand new, it doesn't matter if it's 45 years old. If we look over the likelihood of occurrence, yes, there is the likelihood of occurrence here of an arc flash because we have covers off, we're testing, everything's energized. We make one mistake, we have a short circuit or a ground fault, and we are going to be in the middle of an explosion. So this table can be used with either method that we chose to generate our labels with. And it goes on. Also, this is a nice change in my opinion here, that 130.5G, a table that actually came from Annex H of the 2015 version of 70E. So this used to be in the annex. Now it's in the regular sections of 70E. And what they have done here is they have given us the personal protective equipment that we need if we are using the incident energy analysis method. So, and of course, that's the full-blown arc flash study. So if we're doing the full-blown arc flash study, it now tells us exactly what we have to wear all the way up to 12 calories. So what I like about this, and I became aware that many people in my classes that I teach didn't even know this existed in the back of the document, and they wanted to mix the two methods together when they chose their PPE, which we never could do. This really spells it out for us. So from 1.2 calories all the way up to 12, we have to have an arc-rated clothing system that's equal to or greater than the estimated incident energy. So I look at my label, and I see that I've got 10 calories per centimeter squared of incident energy. I can put a 12 cal shirt on. That's no problem. I do not have to put a flash suit on because it says long sleeve shirt and pants or coverall or arc flash suit. So that's a big difference between the incident energy analysis method and the PPE category method. Because with the PPE category method, I had to put a flash suit on when I got above 8 calories. Here, and the manufacturers are making clothing all the way up to 12, which is nice. So I could have a 12 cal shirt on, 12 cal jeans, put my hard hat and face shield on. I can purchase a hard hat now with a balaclava built right in, get my gloves on, and really, if I'm wearing the shirt and pants throughout the whole day, I mean that's my work uniform. Really, then I'm just throwing on my hard hat and gloves. So it makes it quite a bit easier for us. But this method, this table will go with method number 1. This is also, in my opinion, a great change. So generally speaking, employees have to wear rubber insulating gloves with leather protectors. So we know that. But what's new? Rubber insulating gloves shall be permitted to be used without leather protectors if we can satisfy these conditions. No activity that's going to risk cutting or damaging the glove. The gloves have been electrically retested after I do this, and the voltage rating of the rubber insulating gloves shall be reduced by 50% for class 00 and 1 whole class for classes 0 through 4. So because we don't have the leather protector on, but they're going to reduce the rating of that glove. But if I took a class 0 glove, which is rated for 1,000 volts AC, then, and if I was going to use it without the leather protector, it would now be good for, a class 00, which is 500 volts AC. So I could still work around 480 with that class 0 glove, and I wouldn't have to put a leather protector on there, as long as it wasn't going to risk the chance of it getting cut or damaged, whatever I was doing. Good example would that be if I had a large cabinet and I had multiple voltages in there, and maybe, I had to protect myself to that higher voltage, but all I was really doing was going through the display of a variable frequency drive. Well, I know I have 480 to my left, and I know it's exposed, and I know I'm supposed to wear the PPE, but those leather protectors make it a little tough on dexterity. So if I could take those off, then I could scroll through the display of that drive very easily. Some standards for personal protective equipment that changed: conformity assessment. So now when we purchase our personal protective equipment, the manufacturer or the supplier has to demonstrate that it does conform with the appropriate product standard. And they have 3 ways that they can do this. They can self-declare that it conforms. They can self-declare under a registered quality management system. Or number 3, the one that we're most familiar with, probably certification by an accredited independent third-party certification organization. So that's the one that, would be UL or ETL or CSA or TUV. So any of those, right, would satisfy this requirement here. Marking on my personal protective equipment. So everybody that supplies or manufactures this PPE has to provide us with some information, and somewhere it's got to be on there who actually manufactured it. So the name of the manufacturer, the product standard that it conforms to, the arc rating. So we're going to have to know how many calories per centimeter squared that clothing is. And then we need some identifiers: model, serial number, traceability code, and then how to take care of that personal protective equipment. So how we're going to launder it, things like that. So that all now has to be on our clothing. Okay, so this is a great change in my opinion. Now we are looking at method number 2 to generate our labels and our personal protective equipment, what we might have to wear. So this is the PPE category method. Table 130.7C15 has been in these editions of 70E for the past 3 cycles. So if we look at it, we can see some equipment to the left. And if we look at the very first one, panel boards or other equipment rated 240 volts and below. So that's great. Well, people might want to just say, oh, you know what? I've got a 208 42 circuit lighting panel over here, so I know it must be PPE category 1. Well, you can't really say that because voltage is not one of the determining factors of incident energy. You can see underneath that statement, panel boards or other equipment rated 240 volts and below, we have parameters. So to be able to use this table, we have to satisfy those parameters. And so the fault current, it cannot be over 25,000 amps, and our clearing time can't be more than 2 cycles. So and the fault current was always pretty easy to calculate. There's a lot of different ways we can do that. I have an app on my phone I can do it with. I've got software I can do it with. I've got a nice little tiny formula that we can actually even do longhand. But the clearing time was another issue. So what have they done? They put some informational notes to this table and told us that for current limiting fuses, those are going to have a typical clearing time of a half a cycle. For molded case breakers, less than 1,000 volts with an instantaneous integral trip, 1.5 cycles. So this is excellent that they have given us some guideline with clearing time. And I can tell you that people that come to our 70E 2-day seminars, we really go through this method a lot, because if it's a smaller facility and they don't have labels, this is an easy way to at least get the worker in the right PPE. Personal and other protective equipment. So we've already seen this slide. I'm sorry. Had it in there twice. Okay, so now I want to give you an idea that TPC Training has now gone to some online courses. You don't always have to come and sit in a hotel room, and we don't always have to come to you. And so one of our online courses that we're going to be looking at is going to be on October 13th, and it is going to go through not just the changes of NFPA 70E, but the implementation of it. So, and I'm going to be actually teaching that course, so I'll be doing that on October 13th, and I'm going to give you an idea how to calculate fault current. I'm going to give you an idea how to use method number 2 and satisfy all those parameters. I'm going to do a lot of risk assessments. So that's going to be a nice course. It'll be the one of 3 that I'm doing that week. So I'm doing a code class that week and some grounding and bonding, and then I'm going to do safety on the end of that week. So if you get a chance, love to have you take the opportunity and be able to ask some really good in-depth questions, and we'll be able to walk right straight through NFPA 70E on that day. So this is the perfect time for questions, and so John Busumaya has been monitoring the questions for me. So John, if you have any, now is the time.
Yeah, of course, the first question we always get is the presentation going to be available? Again, as I mentioned earlier, yes, of course it will be. You'll receive an email thanking you for attending this webinar at the conclusion. So please just respond to that email with request of the webinar presentation, and I'll be sure to get that out to you. But Bob, we actually haven't had anybody submit a question. So if you do have a question, please go to the control panel there on the bottom where it says questions and type in your question, and we'll hang out for a little bit here to answer any of those to make sure that you guys get those answered. But so far, we haven't had any submitted. So
also, I'll mention this, that you can see my email address up there. So I do answer a lot of questions, you know, after the webinar is over. So that will also be no problem. But this edition of 70E will certainly impact us, especially doing risk assessments and also having to do some understanding of our workers and their abilities, being able to recognize overcurrent devices and the clearing times. So this edition of 70E certainly will impact us, and I hope that you all get your copy when it comes out on September 25th from the NFPA, and you can look at it and give me any type of feedback that you might, you know, want more information on. It's completely up to you.
Bob, we do have a question now. Someone is asking where they can purchase the new NFPA 70E books.
Okay, so that's a great question. And you're going to have to go to nfpa.org. So that is the NFPA's website. You go there and you just type in their search box, 2018 NFPA 70E. It will come right up. If you do that today, then they're going to give you the opportunity of prepaying for the document. But it's not going to be available to be downloaded until September 25th. You can actually have it in a PDF format. If you want the hard copy of the book, I think you're going to have to wait about 2 or 3 weeks after the PDF is released. So if you want the hard copy, you're going to have to wait just a bit.
Bob, I think you answered this question already, but what date is the 2018 edition effective on?
Okay, so that's a great question. And here's what happens with all NFPA documents, is that the month that they are released in, they will become effective at the end of that month. So we're going to get ours on September 25th. It will become effective on October 1st. They don't give us much time. So all those documents, they're just built that way. And that's one of the slides that I'm going to have in my presentation when I do the online course on October 13th. I will actually have that slide in there as soon as I get the PDF. We'll be very accurate about that. But it's generally the end of the you get, it comes fast. So if I'll give you a good idea, in 2015 they released it in July. Well, that thing was effective, at the end of July. So we don't get much time, that's for sure. Now, the National Electrical Code is a little bit different because states adopt that, and states can adopt really any portion of that book or all of it. They can even not adopt it if they don't want. But with 70E, because it's enforced by OSHA, it becomes effective almost immediately. So,
Bob, one of our attendees is asking where they can find more information on the absence of voltage tester.
Okay, so excuse me, that can be found at any of the manufacturers. The slide that I showed, Panduit had theirs. Fluke, of course, has them now. So if you go to the manufacturer of meters, and then you can go ahead and get that specific information from the manufacturer themselves. But what I did is when I saw this come up in 70E, I just typed in absence of voltage testers, and I got that picture that I showed you. But every manufacturer has them right now. So whoever you normally get your meters from, I would go to them and say, hey, show me that new product that is on the market today.
Right. This next question is about PPE, Bob, and it states, why don't fire-rated clothing have test dates or expiration dates?
Okay, so that's a great question. So first, I want to mention this, that no longer electrical workers can wear FR clothing. So fire-rated clothing went out about 2 cycles ago with 70E. They now have to be arc-rated. So they have to have a label on there that tells us the rating of the clothing in calories per centimeter squared. If there is a rating on that clothing in calories per centimeter squared, then we do know it's arc-rated. And it could also be FR flame resistant. It could be both, but it is definitely going to be arc-rated. And then if you go to the manufacturer's instructions on how to launder them, they are going to give you an idea of how many cycles of laundering that equipment can withstand. And of course, we have to make sure that we are using the proper detergent, that we are using also the right temperature of the water and drying the clothing in the correct way. But if we follow those recommendations that the manufacturer gives us, they will also tell us that it's good for 55 launderings, or it's good for 150 launderings, depending on the fabric that was used. So I know Nomex you can launder a lot longer because it's tougher clothing. If you go with Endura, which is treated cotton, you're not going to launder that one as much because it's more lightweight.
Okay. And this next question is actually right along those same lines. If leather protective gloves are not required, does that have to be stated on the arc flash label?
No. That's going to be with our risk assessment. So if our risk assessment, as we complete that, gives us an indication that there's no chance inside that piece of equipment that my glove could receive a cut or be torn, then I can go ahead and not put the leather protectors on. That does not have to be on the label. It can be on the label. We can put additional information on that label, but the label really is required to only have 3 bits of information on it: the voltage, the arc flash boundary, and either the incident energy or the PPE category, depending on what method that I used.
All right. And that's all the questions that we have, Bob. So with that, I'll let you wrap it up.
Okay, well, I want to thank everybody for attending, and if you have additional questions, you see my email right there, and I will certainly get back to you. We have other webinars that we have uploaded on YouTube, so if you search for this one, you'll probably see some about the National Electrical Code and you name it, boilers we have on there. So just want to let you know that TPC Training Co. is here to help. We can hopefully take care of all your training needs, and we can also give you any help that you might need with electrical safety programs, with any type of consultation you need. You just email that address that you see right there, and we'll get you to the right person. Thank you so much for attending today.